what we can say, lung cancer detection application development. Prior to that, in the next few minutes, what I will share with you, what today morning we discussed this example, what we can call the perceptron learning. Just I will just sharing setting I have to change so that share. Okay, so in the morning, what we have discussed, this perceptron learning algorithm. So where three patterns were there and weight vector and all these things. So on the paper, up to the 3 steps you can do it. Step 1, step 2, step 3. But really, if you want to go for the actual thing, if you want to see it, you have to write a code for that. Let's say you want to write a Python code. So what happens? Let's see. Okay, now it is you are observing this Python, that means Google Colab, and the Google Colab you will also observe this Python script related to perceptron learning algorithm. So I will little magnify it so that we will observe these things very nicely. So this is a Python script where whatever the vectors you have, x1, x2, and x3, these 3 vectors are there. Desired thing is given, then constant value, and what you can say weight vector is also given. So all these things, as per our discussion, we are calculating net value, and then the net value is given to the bipolar binary activation function. If net is greater than 0, you will get the +1, otherwise -1. This thing is going to happen. And finally, you are applying these steps, 1, step 2, step 3, and see here, if I run this code, what happens? Okay, so in the initial step, just observe what is happening. So first you got the net is 2.5 in the step 1, and you are also observing here, initially you got net value step 1. Step 1, this is the net value 2.5. You got it. Okay, and here you are, we mentioned that there is a match, mismatch is there, so weight updation is required, and you got these weights. So here you will also observe the same thing. So 2.5 is the net value, you got it, and after that updated weight vector is 0.8, 0.6, 0, 0.7. Okay, then after that in the next step you will get -1.5, 1.6. So here in this on this page you will observe that -1.6 is the weight value you got, net value you got it, and after that net value weight updation is not required because match happens. Then you will apply x3, and -2.1 is the net value got it. So let's see what the program did it. So in the second step, weight updation will not take place here. Same weight 0.8, 0.6, the same weights are here. Okay, now in the next is -2.1, -2.1 you got it, and here the weight updation took place now. Okay, so step 1, step 2, step 3 completed. Later step 4 is, this is the net value, weight updation took place. Step 5, net value, weight updation took place. Step 5. So this is going to happen multiple steps, and finally, so when the program waits here you will observe that there is no change in weight. There will not be any change in weight here. Yes, so all the steps here, no change in weight, here no change in weight, here no change in weight. So that means if you apply x1, x2, or x3, whatever you have expected is happening. Whatever you have expected is happening. So this is the Python script, and the Google Colab you can very easily create such programs, and I will also share this with you, this perceptron learning related, this file and this one. Okay, this program. So you can use any software, not only the Python. You can use the Octave, you can use the MATLAB, or you can use C, C++, Java, whatever it may be, and try to develop such, what you can say, codes. Very easily you can do it. So once again, very quickly, I will run for you, and you know that single neuron model you have implemented, and this is the result you got it at the output. Okay, so this we have discussed. Now, what I want very quickly, just a minute. Okay, so I think all of you understood what is discussed in the Python, how you can do it very quickly. You might have got it. Okay, so now the next task is related to what we call application development. So I will share with you one presentation. This presentation gives you idea about the error backpropagation algorithm. Okay, error backpropagation algorithm, and I will click onto this architecture. So you will observe this architecture. In the morning we have discussed similar architecture, but now there are changes. Now there are some changes are happening here. So which are the changes and all these things we will discuss one by one. Okay, so this is the architecture where you have the input Z1 to Zi. Okay, inputs here you will apply. So this is the input layer, and there is one additional input that is called the bias. That is called the bias. We will talk about this bias after a few minutes. Okay, then there is a hidden layer. There is a hidden layer. Then there is an output layer. So hidden layer outputs are referred as Y. We are denoting it to the data Y. Final layer, that means last layer or output layer, its outputs are denoted with the letter O. Input pattern is denoted with the Z, as well as there is one additional input called the bias. Okay, so this bias input you are observing it is -1. Okay, as well as in the hidden layer also we have one bias input. The function of the bias, why bias we use it? Actually, during the algorithm discussion also we'll talk about it. But now what I just want to say, bias additional input will help you during the training. If the training do not progresses properly, then definitely this bias will help you to adjust the weight values. Because in a monotonous way, if you are changing the weight, suddenly you are observing that the input is -1 here. All other values input side are between 0 to 1. Input is -1. Okay. So, yes, any difficulty? Yes, any question is there?
Somebody
No.
not muted, so I am muted.
Okay. So the thing is, what you have observed here is there is bias is additional input. Use it for the lung cancer detection based system development. Okay, that is the task what we have here. Okay, so already you know that this architecture where you have three total 2 layers, hidden layer and output layer, and the input layer is there, but mostly we are not counting as the input separate layer. Okay, that we have already discussed. And dummy neuron is also you can mention here for the additional input. Okay, so next slide. When I go for the, what happened? Just a minute. Yes, this is the this figure will give you some idea about how you are going to develop this lung cancer related application. So database creation is very important. Database creation. So last in this figure, in this block diagram, you will observe here artificial neural network, and this artificial neural network, prior to that there is an input. Input is from the chemical vapor sensor array. Chemical vapor sensor array, and this sensor network, or what you can say, this all these sensors gives you some output, electrical potential. Okay, so and this electrical potential, some quantitative value is applied to the artificial neural network. In the morning you have asked how these things can be numbered. So here the actually what happens, we inhale, exhale air, inhale, exhale, inhale, exhale. So exhaled air, out air from the human body have some, what you can say, the chemical compounds in that air. So these sensors are designed specifically for the sensing of these chemical compounds. Okay, and if certain chemical compounds are there in the air, without air, then definitely that person is suffering from the lung cancer. That is what you can say, it is proved already. Medical science knows it. So these are the chemical compounds are there when the person is having in this air, without air or exhaled air. These chemical compounds are present. So this database is available in the hospital. This database is available in the hospital. Okay, so then you may ask me why this is required, why this application is essential. Any idea? Anyone wants to inform something? Why this specific, what you can say, the application is essential? Yes, from the participants. This application, when the suppose we remote places, what are the hospitals are there? In the hospitals, we do not have the expert doctors. So at that time, this expert system will help you. Neural network, trained neural network architecture will be used for the screening purpose. That means imagine for the time being a remote place, remote village, where on a computer, this expert system is deployed. That means now we are going to learn how to train it and all these things. Assume for the time being that training is over. Expert system is with you. Expert system developed for the lung cancer detection using multi-layer feed-forward network. Okay. This expert system, you deploy it on a computer in a remote places. Then let's consider one patient turns and there is one technician. Technician will have chemical vapor sensor array with him. Technician will just put that chemical vapor sensor array in front of the nose of the patient and try to get exhaled air onto that chemical. Breathe out. The technician will inform to the patient, breathe in, breathe out, breathe in, breathe out. So when at the time the breathe out, whatever the outputs available of the chemical sensor array are connected to the computer. Okay, and in the computer we have that program, pre-processing program, where all these numerical values are applied to that architecture, artificial neural network. Then what happens? That architecture will give you output, and from that output you can say that whether the person is that machine program will inform that the probability of having lung cancer, chances of having lung cancer, and that is a very good screening. What you can say, very good screening. There is no blood test involved. There are no CT scan, MRI, and all these things are not there. Then if some suspicious cases are there, then that can be forwarded to the expert doctor later. Okay, so this is, and there is no cost involved also. A simple computer is required where this program is deployed. So that is the advantage of having what you can say, the expert system requirement. Okay, so here we got one thing, a question that means in the chat bot, when human expertise is temporarily not available. Yes, that is the thing what you have mentioned. Okay, so very good. Now, next slide, what he says, just a minute. So this figure gives you some idea about what you can say, all these chemical sensors. Total near about 11 such sensors are there onto this figure. Okay, so just a minute. It is not. Yes. Okay, this architecture. Actual now architecture you are observing, there is a sensor one output is connected to the first neuron, sensor 2 output is connected to the second neuron, like that total 11 sensors are there. That means now you have defined that 11 new input neurons are required because 11 sensors are there, as well as one more additional is bias. Okay, one more additional is bias. So total 12 neurons are at the input. Number of the hidden neurons here in this figure 4 are referred. There is no hard and fast rule that how many neurons are required in the hidden layer. Okay, you can have your own, what you can say, decision, and you can select 4, 5 or 12, 15, 20, whatever it may be. Okay, during training you will get idea how many neurons, that means you go on changing the number of the hidden neurons. Okay, and then at the output side we have total here 1, 2, 3, 4, 5, 6, 7, 8. Total 8 neurons are there. And here it is somewhat, what you can say, the blurred text is there, but just try to imagine that some name of the chemical compound is written. Chemical compound, first chemical compound, second, third, fourth, like that. Total 8 chemical compounds responsible for the lung cancer. So if all these 8 chemical compounds are present, or more than that, means a maximum number of the such chemical compounds are observed at the output, then definitely there is a chance that person may be suffering from the lung cancer. Okay, so what we have discussed here, we are going to create an expert system. For that purpose, we require neural network architecture. Next task is to discuss how many input neurons, how many hidden neurons, how many output neurons you require. So now we have total 11 sensor values. So 11 input neurons. One more is additional is bias. That is a dummy neuron. Then hidden neurons. Then output neurons. Output neuron depends upon desired value. What is desired? That means in this data set, in the pattern, first pattern, we have, let's say, the 11 values, and at that time 8 values are in the desired vector D. 8 values are in the desired. This is the first, for the first patient, this database is stored in an Excel sheet, say, spreadsheet. Then second patient, 11 values, 8 output values, these numerical values. Okay, third patient, fourth patient, like let's say we have 1000 patients data available. 1000 patients data available in a spreadsheet or a Excel sheet, where we call this data is used for the training purpose. So train data and test data, these two are the different things. For the training purpose, we have 1000 patients data available, where input values are specified as well as the desired values are also specified. You know that that pair is required because this is a supervised learning algorithm. This is a supervised learning algorithm. Okay, now this algorithm starts. Now we are going to discuss this algorithm. It is called the backpropagation algorithm. It is called the error backpropagation algorithm. And as you have studied what you call delta learning rule, so very easily you will get idea about error backpropagation algorithm. There will not be any difficulty. And this algorithm is very useful. This is also useful for the convolution neural network design as well as the deep neural network design. Okay, so very important algorithm. So try to learn this algorithm in such a way that whenever you will be using any tool, you should be able to use it effectively, efficiently. You should know all the terminologies. Okay, so what it is written here, you require Z1 D1, Z1 D1, Z2 D2, ZP DP. That means all these pairs. So let's say we have 1000 such patterns are there, 1000 patients are there. That means Z1, Z2, Z like this, Z1000 as well as D1, D2, D1000. These pairs are available in the training data. Okay. Now, what it is written? Eta is greater than 0. Next step. This algorithm we are discussing, error backpropagation algorithm, and this algorithm you can implement it. In the morning, we have discussed perceptron learning, delta learning, similarly with some mathematical model. Similarly, here you are observing some mathematical models. So eta value, eta is greater than 0. So this is a learning constant. Okay, when you use weight updation rule, this eta constant value is required. Okay, E maximum error. Error is what? Error is nothing but the desired minus calculated output. That is the error. So error maximum is chosen. how much maximum error will be there, I'm happy with that. That means error value, you can say that 0.001. It's okay. Ideally, error should be 0. Ideally, error should be 0, but practically you may not achieve it. So some value you have to specify in the algorithm. Already we do that during the programming. Okay. The next important step is here. This formula you observe. O is the output equals to F. F is used here for the sigmoidal. W into Y. You know that in that architecture here, sorry, I will just observe this figure once again. Observe this figure once again. Z at the input. Hidden neurons outputs are referred as Y. Output neurons output are referred as O. Weight values for the output layer W. At the input layer, weight values denoted with the V. V. Y is used for the output of the hidden layer. Okay. Now, so observe this equation. O, that is output, is equal to sigmoidal or a function of net. This is called the net value. You are getting the net value. That's all. Okay. Now, error value calculation. We have seen such equation in the morning. Error equals to 1 by 2 d minus o square plus error. So for in the algorithm, this is the way how we calculate error value. Okay. Then we have also studied delta learning rule. And while studying, this is somewhat modified here. Delta learning rule equal to 1 by 2 d minus o minus k square. Okay, this is for the output layer, and for the input layer, hidden layer, we have 1 by 2 1 minus o pi, and this is the net value calculated. Where this value is calculated here, where do k is used. That means previous weight values. So these two mathematical notations are already there. Proof is also available in the many textbooks. So from where we got it and all this thing, this is designed by engineers, machine learning engineers. These models have created based upon the delta learning rule. Okay, its proofs are also available in the literature. So we do not have that much time to go into that one, but just I am giving you the idea here that after calculation of the error, calculate delta value at both the layers, output layer and hidden layer. That's all. Okay, now we are turning towards the final steps. After calculation of the delta, you have to calculate the updated weight. So here updated weight equals to W. W is the updated weight equals to old weight plus eta. Eta is a learning constant. Delta value we have calculated for the output, and here Y is nothing but the output of hidden layer. So this formula calculates updated weights at the output layer. Then another mathematical notation here will calculate the updated weights for its previous layer. That means we are calculating from output side to the input side. First we calculate updated weights at the output side, W. Then we go for the input. So here V equals to old weight plus eta is a constant, and delta value already we got it. Z is the input. So using these two mathematical models, you are getting updated weights for both the layers. Okay, it is a multi-layer network you are using. Then what happens here? What the other steps are saying that we will discuss. Just try to imagine for the time being. Imagine in such a way that you have a database with you. For 1,000 patients. This is referred as a training data. Now in the training data, what you have? Total, how many values are there? 11 values are there. 11 values for sensor values. Okay, and 8 values are there, chemical compound related. So in the first row of that vector, first row in that database is related to 11 values in this application and 8 chemical compound values, right? Like that 1,000 patient data is there. You apply the first pattern, When you apply the first pattern, what happens? You apply the first pattern, calculate the output, then calculate the error, then calculate the delta values, then calculate the updated weights, then apply the second pattern. Then do the same thing. Apply the third pattern. Do the same thing. Apply the fourth pattern. Do the same thing. Like that, apply all the 1000 patterns. Apply 1000 patterns. Then observe how much error is there after this first cycle, because first cycle is completed. After completion of the first cycle, once again apply all these 1000 patterns in the second cycle. Calculate the error. Apply all these 1000 patterns in the third cycle. Calculate the error. Go on calculating error. Observe error. Error should decrease. Error should be equal to, let's say, the 0.001. And if the error reaches to 0.001, then you stop the training. Okay, then you can stop the training. So this is the process what we are using it during the training process. Same thing we did it in what you call, same thing in the perceptron learning you did it. Okay, so these were the few points. Then how to use this trade algorithm, that also we have to discuss, and that we will discuss very quickly. So this initial what you can say, the thing we studied, algorithm we have discussed, and still we have not completed that discussion. But prior to that, I may that I wanted to see, is there any what you can say questions? Are there any questions are there from the participants in a chat? Or so if you have any questions, because they now last half an hour we are discussing it to avoid what you can say monotonous thing and to be interactive. I'm expecting a few questions. This is afternoon session after lunch, and it is very difficult for what you can say the listener to be awake after lunch time, specifically after half an hour and all these things. That's why what I thought that I will have a small what you can say interruption here related to checking where is there any questions in the chat bot or this thing is available. Okay, so as such, there is no what you can call any thing related to multi-layer perceptron. Now I want to talk to you about how you are going to use this algorithm actually in practice, actually for the lung cancer detection. And prior to that training procedure, we are also going to discuss. Now, what as a machine learning engineer, what should be your approach? We have just discussed the algorithm. We have just discussed the architecture. Okay, so that architecture and application, based upon that, now our next task is to define the role of machine learning engineer. Okay, so for that purpose, I will open a small note page, and we will discuss with the help of that. Okay, so just I'm opening it. So same example, but related to the training procedures, we have to talk about it. Okay. Now I'm sharing with you one application window. Okay. So the same application and your role as an what you can say the trainer, machine learning trainer. So this algorithm, now you have, let's say, the Python script algorithm is implemented and all these things. But what is your role there? So let's see here database what you have. So in a Excel sheet, you have all these 11 values. I will write, let's say, sensor values are there. Say this is some first, second, third, fourth, fifth, right? Like this total, say the 11 values are there. 8 values related to the chemical compounds. Okay, like this is for the first patient, second patient, third patient. Like this, you have 1000 patients data. This is referred as a trained data set. data set training. We are using it for the training. Okay, now in this data set, we have this architecture. Let's say total 12 values, 12 inputs are there, because 11 are for this and 1 is for the dummy bias. Okay, this 12th is for the bias. Then hidden, and then these are the output neurons. Okay, so these 11 values you are applying at the input side, and the weight values are updated. These weights V and here W, and these outputs are here, where you have the desired things and output values. Okay, so what happens? Let's say we want to talk about these cycles. We want to talk about training cycles. So I will draw one graph. Just observe this graph. Just observe this graph. On the horizontal axis, I am writing cycles. On the vertical axis, I am writing error. Now, cycle 1. Cycle 1 means what? All the 1000 patients data you have applied. Okay. To this algorithm, let me see here, input values are connected. Then we are observing output at the here. Here, activation function and all these things already you have selected to each neurons. Okay. Randomly weights are assigned initially. Now, during training, weight changes. This W weight changes, V changes. This change in weight is important. Training happening means. Okay. So all the 1000 patterns are applied. That is called the cycle 1. And observe how much is the error. So error value is here. Then second cycle. Second cycle, some error is decreased. Third cycle, error is somewhat decreased. Okay. And like this, all these many such cycles are there. 1000 cycles. And you will be very happy that if error decreases. And let's say the error is 0.001. You say, yes, I got it. For this, that means, let's say more than 10,000 cycles. That means all these 1000 patterns are applied for the 10,000 times, and I got this graph, and I'm very happy because error is minimum. Say this is ideal situation. This is ideal situation. Okay, error is minimum. Done. We consider for the time being this situation. Okay, so here what you have V and W. These weights are there. These weights are there. Train weights achieved after the training. Okay, that means your training is successful. Now you have to use this in a hospital. So in a let's say remote place, you will create an architecture where 11 inputs are there. Then let's say the 4 or 5, 4, what you can say, we had used neurons in the hidden during training, and total, what you can say here, 8 neurons. So at these connections, you apply all these V and W weights, because these are the trained weights. These are trained weights. You apply all these weights here. Done. Now, new patients arrives. We have not, what you can say, used during the training. New patient arrive at the hospital. You know that this is a properly trained system. So apply for the new patient all these 11 values, what you got it from that sensor at the input. These trained weights are available. So multiplication and all these things takes place. And here we got some output. So all these output values are available related to chemical compounds. Okay. And if these, out of these 8 neurons, if more than suppose 5 or 6 neurons got prominently some higher output values, you say that there is a presence of all these chemical compounds, and there is more chemical compounds are present. That means there is very good chance that that person is suffering from lung cancer. Okay, without having any blood test, without having any CT scan, nothing. Simply getting the sensors output connected to the neural network, and then get the output and observe. And any layman also can say something based upon this by observation of these numerical values. Done. So in this way you can use it very easily, train neural network, because the data what you got it, this training, these V and W are very important for you. So role of the machine learning engineer is to get this weight vector. Now what is the difficulty? You will say it is very easy. It is very easy. Simply try to observe this graph and do that procedure. But practically, this graph will not be like this. When you try to observe these graphs, you will observe that this graph may be like this and there is no further change. It remains plateau stage will be observed. There is no change. Okay, here error is not decreasing. What to do in that situation? Another situation may arise during training is like this. Okay, error decreases, then start increasing, then decreases, then start increasing. So you don't know which is the minimum error value, this or this, then you start increasing. This situation may arise. So this is called the local minima. This is called the local minima here also. But how to come out of this? That is the problem. Okay, so what is, you will say that I will go on increasing what you can say cycles. I will go on increasing cycles, but how many? Let's say the 1 lakh cycles, but it takes, let's say, the more than 24 hours or 36 hours for the training purpose. For how much time you will wait it? That is also a problem. Then another thing is, you will say that I will go on increasing the, instead of 1000 patients, I will have the 10,000 patients data. The database will increase, but increasing database may not be sufficient many times. What happens? Training time increases. Training time increases, saturation occurs, neural network will not run later, and you may not get the proper results. So all these difficulties are there during the training. So what to do? What to do? Most important thing is, so when such situation occurs, what you have in your hand is the eta, learning constant. If you selected this 0.5, then make it eta in the some training process is 0.6. That means suppose the error decreases here and there is no change. At this point, you stop the training and change the eta from 0.5 to 0.6. Okay, eta is a learning constant. Okay, learning constant. This you can change it. Then we have also discussed in that network what you can hear here in the logic unit or activation function. Let's say the 2 upon 1 plus e raised to minus lambda into net. So this activation function you can change. Instead of the lambda equal to 1, you can make it 2. You can make it lambda equal to 3. You can do this. Okay, in the program, you can all these things, you can change it. Okay, what we have discussed, you can try to change the eta learning constant or a lambda. Or otherwise, you can change the activation function. Instead of using bipolar binary activation function or a nonlinear functions, you can use the ReLU activation function or any other such hyperbolic, tan hyperbolic functions. Such functions are readily available. So make these changes. What else you can do? See here, you do not have control on the number of the input neurons. That means 12 input neurons are there, 4 hidden layers and 8 output neurons. So here you have the facility to change hidden hidden neurons. Instead of 4, you can make it 8. You can make it 10. You can make it 12. You can make it 2, or you can make it 20. So many possibilities are there. Many possibilities are there. So refer all these possibilities and try to change it. Ultimately, what is your requirement? Your requirement is to get proper graph where error value decreases and here 0.001 will be the maximum error value available. This is your requirement. But what are the how many times you are going to do it? Because here you are changing eta, you are changing lambda, you are changing activation function, you are changing hidden neurons as well as hidden layers. That means in this architecture, you have, let's say, 12 input neurons, and here let's say the 4, then here 3, then here 5, then total 8 neurons at the output. That means totally instead of 2, you have used 3 what you can say the hidden layers. So if you use the 3 hidden layers, then this architecture becomes 12, what you can say 4, 3, once again 4, 3, 5, 8. Okay. So total 4 layers are there, 3 hidden layers and 1 output layer. 4 layer architecture, input layer is always considered. So this becomes multi-layer feed-forward network, and we are now, we can say, we are turning towards the deep learning. Deep learning. Why deep learning? Because during the training, if successful training will not happen, very complex data we have, then at that time, increasing number of hidden layers is a solution. But what is the disadvantage of this? Disadvantage of increasing the hidden layers. Network becomes very complex. Complexity increases. Training time increases. Then hardware requirement increases. That means memory increases. Requirement of the memory increases. So all these things happens. Do you have that much memory? Instead of the, let's say, the 8 GB RAM, do you have 12 GB RAM, 60 GB RAM or 32 GB RAM with you? Because these big matrices are there, and the storage, for the storage purpose, we require such good RAM. So these are the few issues with this multi-layer feed-forward neural network. During training, we face trouble. Say, for the 24 hours, you have trained that network, and after 24 hours, you learn that, oh, training is not happening properly. So once again, from the scratch, you have to start. Okay, so these are the few difficulties what you can say the people or the trainers face. So there is a role of machine learning engineer. So these are the some what you can say difficulties we are facing. Okay, so the participants, I have discussed with you what you can say how we can create one application with this example of the machine learning, that means for the lung cancer detection. And I think with this discussion, most of you have got idea about how to use such architectures. We also discuss algorithm. So if you have some questions now, because from the near about more than 45 minutes, we are talking about this the same algorithm, because this is a basis for most of the applications, convolution neural network or the deep neural networks or similar such networks. What you have studied in the last 45 minutes is very important. But I don't know how it is communicated to you. So if some difficulties, some questions are there in your mind, you can put it in the chat. Okay, so because now I have to also demonstrate you with this perceptron, the perceptron learning rule we studied, Python program, and one such similar, not exactly lung cancer related data. I do not have that data, but some other things are there with me that I will show it to you. Python, using Python. So, but better to have some discussion and to avoid what you can say the afternoon sleep duration specifically. Yes. So it seems there are no questions still here, but I will put you on one small exercise for next 10 minutes. We will do something, and then we will continue further, because that is very much essential. So let's. I have some 10-minute plan for you to make you awake. Let's see how it works. Okay. So what I suggest, say what we have learned till now, since morning, many things we have discussed. Why not to quickly find out what we studied and how much we got it, or quick revision or learning. It supports learning, this activity. Now the next 10-minute activity will be used to support it. So what I suggest to the participants, just put in the chat board A, B, C, D, any option related to the whatever the task I will show you. Okay, you have to just put it in the chat what you feel it. Is it A? Is it B? Is it C? Is it D? I will share one what you can say tab of the browser, and there you will observe something. You can read that. Okay, and there are the 4 options are there for the given sentence, given task, and out of that one may be suitable or perfect thing. A, B, C, D. Okay, I will show you one thing, and then later we will try. So this is a 10-minute task we will complete, so that that there will be a good learning. Okay, so I will share with you one tab. Where is that? Yes, I got it. Okay, so are you observing something here? Yes, you are observing something. Very good. So now I will click onto this neural network and a deep learning this menu, and what we will observe here is one thing available for you. That is, yes. Now you are observing something. So can you read this first line? What is the main point of difference between human and machine intelligence? And out of these 4 options, which option is correct? A, B, C, D. What do you feel? Just you put it in the chat that for the this first task, for the task number 1, which option is correct? What is the main point difference between human and machine intelligence? A, B, C, D. Please read it. 4 options and put it in the chat, which is more suitable. Yes, very good. So we got few replies here, right? So let's see. Finally, I will show you. I will give the correct what you can say answer for this also. So this is a quick what you can say the revision for you. Then let's say I will click it here A. Then go for the next. Perceptron learning rule uses which one? Perceptron since morning many times we discuss about it. Supervised, reinforcement, unsupervised, or combination. Perceptron. You know that we have desired things. CD. Which one is correct? Which is the correct? A. Also we got it. B. We got the different options here. Participants are giving. Very good. So you are putting. Yes, yes. So you are putting it very good. A, B, C, D. Few answers we are getting. Very good. So let's say I will put it here A. Let us we will check it is it correct or not. Now the second after that third point, feed forward networks are used for feed forward. We have discussed this network is a feed forward. Just now we discussed pattern mapping, pattern association, pattern mapping, pattern association, or pattern classification, which is correct. Okay, so A, B, C, D, which might be. Let's say we will put it here answer as a C. Later we can check it which is correct or not. And in the chat board also you are putting some answer. Very good. So after this we will go for the next page and just try to read it. Read it. Which is correct. Which is correct. A, B, C, D. Let's say I will put it D. Let's check it. Next is the function of dendrites. We have studied in the morning biological neuron. So dendrites, what it will do? Try to put in the chat. Participants are giving answers in a chat. So read it. The function of dendrites. Let's say I will put it here, receptor. We can check it later. Okay, then 6 number. Which is correct for the 6. Signal transmission at a synapse is a chemical process. Let's say next page. Read it. Task number 7, which is correct. Let's say we will put it at the C. Okay. Question number 7. The next one, 8th. 8th. Which is correct. Let's say I will put it C. Next. Question number 9. Question number 9. Let's say yes, I will say yes. Then last 3 are remaining. Put it in a chat for the 10. Question 10. Yes, very good. Most of the participants are putting answers in a chat. Very good. So this is really happening interactive session, and quick revision is also happening. So learning is A, B, C, D. Let's say I will put it A. Go ahead. 11. 11. Which is correct. Let's say I will say 12. Sorry, I will say neuron, B. And the last task. Yes, last task. Hebbian learning, it is unsupervised. Okay, finish. Now we will finish it. Let's see, answer saved. Submit all and finish, because we want to see what are the correct answers we gave it or not. So here right side it indicates that most of the answers are correct. Only question number 7 we gave the incorrect answer. So I will click onto this 7. What it says, what is unsupervised learning? Oh, so here the correct answer is absence of teacher. Already you know that. So, but by mistake we have kept it. Groups may be a no. So absence of a teacher is very important. That means in a unsupervised learning. Okay, in this way, very easily you can learn related to this machine learning. This is a quick revision, you can say. Okay, so 1, And how many marks we got it? One answer is incorrect. So that's why 9.17 out of 10, 92% marks we got it. The group activity. So this is a group learning. Okay, one way of learning or a quick revision. So in the 10 minutes we did it. Okay, so later you can, if you want to later, what you can say, check it, these answers, or if you want to visit it. So it is very simple. In a browser, just you have to search yalikka.ml. This is a web address. Just you have to use this web address in a browser, and there will be one page will open, and then you can access this. That is later part. Later you can do it, and today also we'll do a small task with the help of that. Now last 1 hour is remaining. So in this after lunch we have discussed very important application, development of this algorithm, multi-layer perceptron, and all these things, and the quick revision also took place because of this small exercise what we did it. Okay, good. So participants, please let me know if you have any questions. You can put it in the chat now, because I am going to discuss with you this one Python programming, some demonstration. Okay, very good. So I got a feedback that nice assessment. So really in a group we have learned. Once again, quick revision took place. You have answered it, and that 10-minute, we can say, a small revision took place. Good, very good. So next task is to in the Python, this program implementation, just I will show you, because of time limitation, it may not be possible for us to all the discuss detail, but this demonstration may give you some confidence, okay, related to this. Okay. So next task is perceptron. I will share this screen now, one another tab. So some disconnection took place. Single minute, wait a single minute. Okay, so I will share with you this backpropagation related task. Hello. Yes, yes. Okay, so we are discussing about this how you can do it with the help of the Python. Okay, just observe. Now I will share with you. Just once again, just there was some interrupt, so I will share with this backpropagation algorithm. This is the Google Colab browser-based Python, so it is very easy and very suitable platform what you can have it. Okay, so from the first line you will observe this is Python script, and if I run this Python script, let's see what happens. You are observing it, and at the downside, so this is the Python script. Whatever the backpropagation algorithm we have discussed is implemented here. Okay, and at last, here you will observe here the error, change in error, and one plot is also there. Just I want to show you this plot. This is the plot. Say what had happened here. Error value decreases. Error value only 100 cycles are shown here. Only 100 cycles. Practically, you require many such cycles, training cycles. Okay, in this program, and this error value, mean square error value goes on decreasing as training epochs. We have mentioned the word here, training epochs. First cycle means first epoch, second cycle means second epoch, and all these things. Okay, so epochs and all here you can change it. So network train, x is the input pattern. So this input pattern is shown it here. Then y is the input pattern, output, or we can say the desired, and learning signal, and here 100, that is epochs. So instead of the 100, I can make it 200. Okay, and run this code. So you will observe that here training happens. Yes. So here initially suddenly decrease in error took place, and later error decreases. On how much is the final value, that is 0.02. But we will not be happy with this 0.02. Your expectation is you should make it very small. That means 0.001. But for that purpose, this architecture will take long time for the running. And here you will observe how much what you can say the RAM is utilized and all these things. So this RAM, disk space, this information is already available to you. Okay. So this is the Google Colab session. We used it. That is one thing what I wanted to show you. And there is one more task. This is in this program. What you have seen, only a small input data set. Okay. There is one more program related to the backpropagation algorithm, and that's what I want to run it for your reference. So let's see. So I will also share that one with you. So this sharing I have to stop now. Presently what I am doing it here, and then another tab, this. Okay. So here, just observe accuracy of 120 atoms train data and all this. I will discuss this with you. I will also explain what is that. So this is the backpropagation algorithm implemented in the Python. I will run this code, run cell. And depending upon the data set and all these things, it takes some time. And finally, what you will observe here, yes, bring neural network backpropagation demo here. So learning iris data, so training error decreases, and accuracy of the trained data and test data. So these two numbers are different here. Just I want to talk to you the few minutes about this accuracy of the trained data and test data. So what is the trained data? What is the test data? The trained data is the data which you have used during the training process. Test data which is not used, but similar data set you have. I will show you what you can say one file where this trained data set and what you can say the test data set is shown. Okay, so this sharing for the time being I will stop, and one more file I will share with you. Just observe here. Okay, train data. So these numbers are here. Say first, what you can say these numbers 1, 2, 3, 4. 4 values are there. 5.1, 3.5, 1.4, 0.2, and 100. Last 3 values. So 4, 3. That means 4 input neurons, 3 output neurons. So these 3 values are given here. In this way, we can write it. That means we have our own conventions. So this is one file, text file, where all these data values are kept. Okay, all these data values. From where you got it? From the what are the example we are discussing? This is the classification example related to what you can say the flower classification, species classification, where 4 different species are there of the one flower and its data is given here. So this is initial what you can say the few lines where you have the up to this. See here 100, 1000, 1000, always it is written at the output layer. Okay, that means this is a class for this input data set. Then there is another class here from this point. Okay, the training data set, such data set you can arrange it in Excel sheet, spreadsheet, and that machine learning algorithm takes it. Another data set I will show you here is the test data set. Say only 30 values are here in the test data. Train data and test data. Here, train data, test data. So during testing, for the same experiment, we have the data, but which is not used for the training. And this is the because of the generalization ability, you will observe that you are also getting good results for this. So, so what you have observed here in the example, what we have demonstrated here, just now what I have shared with you, one, what you can say, the tab, where it says that accuracy on 120 items of the train data and accuracy on the test data differs. Definitely it will differ, but good accuracy we got for the test data also. Okay, so these are the few things what you can have, what you can say we are using it for the training. So when you want to summarize what we studied, so the Python can be used very well. In the morning, someone was asking about the Python programming. So for this quick learning, it helps a lot. But actually, when you want to go for development of applications where big data is there, at that time, Python may not be suitable. Otherwise, you require very higher configuration of the machines, RAM and the disk space and all this. Specifically, RAM is very important in such situation. Okay, so these are the few things. Now there are the what you can say, few questions. I think how a particular activation function formula is selected. So this is the question. Activation function means the bipolar binary activation function, non-linear activation function. All these functions. There are the main ReLU activation function is there. Many such activation functions are there in the literature. There is no hard and fast rule related to that, but you should study that activation functions, that means plot mathematically how the plot looks. It compresses which data or which region it considers. So depending upon application, actually you have to read somewhat because of the time limitation. It may not be possible to discuss in all details of the activation functions, but as such there will not be major change in the results. Let's say you are getting 90% efficiency, then slightly you may improve or it may decrease when you change the activation function. But continuous activation functions are suggested. And what today we have discussed, that function is also a very good function, bipolar binary activation function, that also you can use it. Okay, I think participants, all of you got, there is one Google form, Professor Pawan. So it is requested to all of you that fill the feedback form and submit that form there. Okay, so all the participants, you can submit the feedback form. And if you have any questions, meanwhile, you can also ask. That means these two things parallelly, we can do it. Okay, so I will be very happy to answer your questions. You can also unmute yourself or put the questions in the chat. Yes. So that I will get idea about what to discuss next, because there are the many things are there, and understanding of this algorithm and how the Python helps for you, that we have discussed. If you want to talk to you about something related to the solutions, cloud computing solutions or the GPU solutions and all these things, we will also discuss within the next 10-15 minutes. And meanwhile, you can also complete feedback form. Okay, so any questions? Specifically, what you will do when the computations are very high? I showed you with the very small, what you can say, data, very small data set. But data set increases. You can also think about use of the GPU, graphical processing unit, GPU, that helps you a lot for the processing quickly, as well as if you know CUDA programming language for the parallel processing, because parallel processing is very much useful in this type of the algorithms for the quick results. Okay. GPU is one more solution what you can have. Any other things? Cloud computing solutions are also useful nowadays. You have what you can say, you have Amazon Web Services that helps a lot. Then the Digital Ocean also helps a lot for what you can say, this thing. Then the Google Colab, this laboratory we have discussed just now for the implementation of machine learning algorithms. Many such things are there. Okay. So I hope you are you got that form and you are updating it. This one, Google form link. Just click it, open it, and complete your feedback. And if you have questions, otherwise we will also talk about a few more things. So participants, you can complete your feedback, and meanwhile, if you do not have any questions, I think because most of the things I have completed from my side, what we have today planned related to machine learning. There also we have also discussed about the deep learning. So when you have the multiple hidden layers, you can say it is a deep neural networks. Okay, so organizers, anything from your side, anything to any topic, or what is your suggestion? Please let me know so that I can continue. Yes, please. Yes, sir.
Thank you. Yes, sir. So any participants have any queries, you can please raise the queries. And the eminent speaker is with you. Any participants? Can I ask one or two members can raise the questions? Any participants have any queries? I think there is no queries are coming up, sir. So
Yes, sir.
if you are completed, if you feel that, so we will close the session.
Yes, yes. Yes, sir. Okay, sir. Thank you. Very nice interaction. Very good experience from the participants, and really those who have participated were eagerly learning it. And hope this today's session will be useful for learning the next sessions and the backbone of this whatever we have discussed.
So
Okay.
thank
So
you,
many
Dr.
thanks.
Many thanks to Dr. Sanjay. So where all the participants tomorrow 10:30 sharp, the program second day session will start in the morning. So we will share the link also in the morning. Actually, today feedback form has shared in the Zoom platform, Zoom chat box. Please fill it up, and also the participants. So we are also sharing in the WhatsApp group also, so you can fill the form carefully. This forum will have the organization details and the feedback forum regarding the overall program. So particularly regarding the assessment and test, we will conduct another day. So thank you very much, Sanjay sir, and participants also.
Okay, sir. Thank you. Thank you. Now I'm leaving.
Hello.
Ah, yes.
Hello, sir.
Yes, yes.
So
सुन रहे
one
हैं, बोलिए.
question,
Yes.
Professor Shekhar, sir.
हाँ 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 बोलिए.
With so many advanced algorithms,
Mm-hmm.
why machine was not trained like a doctor to treat COVID patients?
Okay, very good question. Why, with the so many advanced algorithms, why this thing is not happened? Treating. Actually, a lot of research is going on. Initially, people were struggling for the testing facility
Yeah.
also, but now
Okay.
by just observing X-rays or a CT scan,
Yeah.
and based upon the machine learning algorithm, the very quick diagnosis is happening. Sometimes what happens, these PCM tests and all these things, they are also not giving the 100% results. But
Yeah.
very good results nowadays, doctors are getting because of the X-ray images. They are just directly giving it to the machine learning algorithm, and machine learning algorithm says that it is COVID positive or COVID negative. So that advancement already took place, and that machines helped a lot, as well as for the COVID vaccination studies, research groups, and analysis purpose, and this protein analysis. Many such supercomputing algorithms, the people have used it. That's why very quick results we got it. It is really a great thing that we got very quickly a vaccine also because of these computing facilities.
Thank you. Thank you, sir. Thank you.
Thank you. Thanks.
Thank you, sir.
Okay.
Okay.
So Professor Shekhar has raised a very good question. So, and hope so resource person has given a satisfied answer there. So any more one or two, any participants are there, or shall we close the session? Because we are closing the session.
Yeah, I want to just ask this thing that Professor Sanjay, he has shared yalika.ml. So for what purpose he has shared? Actually, the credentials are required for that particular site.
Actually, yalika.ml, into that there is also feedback form is also there, as well as the quiz. What I conducted, that quiz or that interactive session,
Yeah.
that is with the help of the yalika.ml. This is a learning management system which I have deployed it, and there I have created one course. What you can say, the deep learning related machine learning and deep learning. So
Yeah.
that I am updating in future when the participants wants to learn something, this Python code or any presentations will be uploaded there. And I have
Okay.
given the that means guest can log in into that one. So
Okay.
there is
So along
no
with guest plus guest.
guest can log in. So there is no requirement of the username and password also. Okay. So
Okay, because I'm getting only 3 links as activated: the feedback, neural network for deep learning, and the last one, multiple choice questions. But the
yes, yes.
meanwhile, the middle part, whatever topics you have mentioned, I am not able to access them. So should I log in as guest in that? No?
Actually, I will enable what you can say these access today or tomorrow into that
Okay.
learning management system, so that you will get these presentations or
Yeah.
what you can say
Yeah, right,
this
right.
Python
Because
code
right,
and all this. Okay,
exactly, because right now it is showing as a logged
okay.
content.
I have to change the settings into
Yeah,
that one. I will
sure.
do it. Yes. Okay.
Sure. Thank you. Thank you so much.
Welcome. Welcome. Thank you.
Any more raising the hands for the queries? Thank you, sir. I think Dr. Sanjay, thank you very much. I think the participants can join the tomorrow session, day 2 session. So 10:30 sharp we are starting the session. The resource person from IBM, they will start the session, and 10 to 20 minutes, 15 minutes before you can join the session. Thank you very much. Session is over. We are closing the meeting.